Okay, let's dive into this. We all use the command line, but have you ever just stopped and thought, how does it actually work? It feels like magic, right? Like there's this little ghost in the machine turning your typing into action. Well, today we're going ghost hunting. We're going to unmask the deep, deep history hiding inside your terminal.
I mean, think about it. You type ls, you hit enter, and a list of files just appears. It seems so simple, so instant. But that simple action hides this incredibly complex story. It's a dance between hardware and software that has roots going back over 150 years. So let's trace that story all the way back.
To really get what your terminal is today, we have to become time travelers. We're going to start before computers even existed, then jump into the age of giant mainframes, watch the rise of the personal computer, and finally land right back here on your modern desktop. Let's go. So, our first stop is way, way back. The basic idea behind your terminal is a lot older than you probably think. This story doesn't start with silicon chips. It starts with things like stock tickers and telegrams.
You see, long before we had processors, people had a really fundamental problem. How do you send text from one place to another instantly? And devices like the stock ticker and the telex machine were invented to do just that. They were basically the world's first remote keyboards. And this, right here, is where our story really kicks off.
And that brings us to our first major clue, the teletypewriter, or as you'll see it everywhere, TTY. The name literally means typing from a distance. This single device, this is the granddaddy of it all. Its name, TTY, is now stamped all over the Linux kernel. So remember that acronym. It's the ghost in our machine. So how did this old telegraph technology jump into the world of computing? Well, when the first Unix computers showed up, and these things were massive, room-sized machines, the developers needed a way for lots of people to use them at the same time. And it turned out that old teletypewriter was the perfect tool for the job. I want you to picture it. There's this giant mainframe humming away in a server room, and you have these long, snaking serial cables running out to dozens of desks. And on every desk is a physical terminal, which is really just a keyboard and a screen, a direct descendant of those old teletypes. Each one was a physical doorway into that central computer. Now, to manage all of these connections, the Unix developers created this absolutely brilliant three-layer system inside the kernel. At the very bottom, you had a driver that talked directly to the serial port hardware. In the middle, this really clever piece called the line discipline handled basic stuff like knowing what a backspace means. And at the top, the TTY driver gave every program a simple, standard way to talk without ever needing to know what kind of hardware was underneath.
But here's the thing, this TTY system wasn't just a dumb pipe for text. No, it was also the session manager. It was the controlling TTY. Yeah, it directed all the data, but, and this is crucial, it also handled signals. When you hit Control-C to kill a program, it's the TTY that sends that terminate signal. It was so central that if you physically unplugged the terminal, the TTY would kill all your running programs. Okay, and now we get to a huge turning point. Those giant shared mainframes start to fade, and personal computers, machines that sit right on our desks, take over. And this created a totally new problem that needed a very clever solution. See, on a mainframe, if you wanted more terminals, you just plugged in more terminals. Simple. But a PC has only one keyboard and one monitor, and they're wired directly in. So how could we get back that power of having multiple separate command line sessions at the same time? And the solution was just pure genius. If you can't have multiple physical terminals, you just create multiple virtual ones inside the software. The Linux kernel itself basically learned how to pretend it was several different terminals at once. You only see one on the screen at a time, but you can instantly flip between them with key combos, like holding Alt and hitting a function key. And get this, just to show you how powerful this idea really is, the standard Linux kernel can actually support up to 63 of these virtual terminals running all at once. Now, most systems only turn on about 7 by default, but the raw capability is just immense. All right, let's fast forward to right now. We're not staring at a black screen with text anymore. We're inside a beautiful graphical desktop with windows and icons. And this modern environment introduces the last and maybe most important layer of our whole story. Now, this might actually surprise you. Your entire graphical desktop, every window, every icon, your mouse pointer, the whole shebang, is usually just one big program running on a single one of those virtual terminals we just talked about. That old text-based system is still running underneath it all. Which brings us to the core of the mystery.
right? If the entire graphical interface is sitting on, say, Virtual Terminal 7, then what happens when you click on that terminal icon to open a new command line window? What is that thing? It can't be a virtual terminal because we're already using one for the whole desktop.
And the answer is a pseudo-terminal, or PTY. And the word pseudo just means fake. And that's exactly what it is. It's a completely fake terminal, a pair of software endpoints made by the kernel that perfectly mimics the behavior of one of those old-school hardware terminals. It is the ultimate act of backwards compatibility.
So here's the complete picture. When you launch a terminal app, that app, the terminal emulator, immediately asks the kernel, hey, can I get a new pseudo-terminal? The kernel creates this linked pair of master and slave endpoints. The terminal emulator app holds on to one end, the master, and it connects your shell, like Bash, to the other end, the slave. And everything you type just flows through this PTY pipe. So this gives us the whole family tree. We started with the original serial TTYs for physical hardware. Then came the virtual TTYs to give a single PC the power of multiple sessions. And finally, we have pseudo TTYs, or PTYs, that let us have terminal windows inside our graphical world. I mean, just stop and think about how wild that is. The terminal window you use every day is a modern graphical program that's main job is to pretend to be a piece of hardware from the 1970s. It connects to a fake software port inside the kernel, all so that your shell can run, completely oblivious, thinking it's still attached to a physical teletypewriter. It's just an incredible stack of history. Okay, so why does any of this history lesson matter? Because when you understand this architecture, you unlock some seriously powerful tools. Take a program like Screen, for example. It's a terminal multiplexer, and it masterfully exploits this whole PTY system we've just uncovered. The way Screen works is by basically putting itself in the middle of that PTY connection. It runs your shells inside its own pseudo-terminals. But here's the magic. You can then detach from the Screen session. You can literally close your main terminal window, but Screen and all the jobs inside it just keep running in the background. Then, later, you can open a brand new terminal and reattach to your session, and everything is exactly where you left it. And that really brings us to the main point of all of this. Your simple little terminal window isn't simple at all. It is a living, breathing museum of computing history. From the teletype, to the virtual terminal, to the pseudo-terminal, each layer is a ghost from the past, an ingenious solution to a problem from a totally different era, all still running on your computer today. So the next time you type ls and hit enter, just take a second to remember that ghost in your terminal, a chain of technology stretching back a century and a half. And it kind of makes you wonder, right? What other digital ghosts are out there, hiding in plain sight?